vibrates with a fundamental frequency of 330 Hz. What are the frequencies of the first four harmonics? We use our standing wave resonance frequency equation. F sub n is n times F1. F1 is 330 Hz, and that's for n is equal to 1. So that's our first harmonic. And then we just substitute in 2, 3, and 4. And our first four harmonics are these numbers right here. A stretched string of length 6 meters resonates in 3 loops. What is the wavelength of the wave? Not a lot given here. We have given the length of the string here is 6 meters. Now what is n equal to? Well, n is equal to the number of positive or negative antinodes. So in this case, 1, 2, 3. We use our standing wave resonance wavelength equation, which is lambda is 2L over n, substitute in our givens, and get the wavelength of this wave is 4 meters. Now let's see how you can picture that. Let's start over here, go up, down, and come back. What's that? That's one wavelength, isn't it? Right? Because you wind up at the same place going in the same direction. And what do we have over here? That's only half of a wavelength. So since the two of them have to add up to 6 meters, this guy here looks like he's 4 meters long, and this guy is 2 meters, right? Each one of these bubbles is 2 meters. So the wavelength is 4 meters, which is exactly what our equation told us. A stretched string of length 6 meters vibrates at a frequency of 2 Hz, producing a standing wave pattern with 3 loops. 1, 2, 3. N equals 3. What is the speed of the wave? We're going to solve this in a couple parts here. We have 3 givens. So first, we're going to find the wavelength of this wave. And if you do a lot of these, maybe you can just look at this and see, here's the wave, and the total length there is 6. So this is 2/3 of that, so the wavelength is 4 meters. Or you can use our equation, where lambda is 2L over n. We substitute in our givens, we're given the length and n, and we get 4 meters, which tracks with what it looks like pictorially. Then we use the wave speed equation, where the velocity is lambda times frequency. Here's the wavelength that we found, here's the frequency that we were given, and we get 8 meters per second.